I'd like to talk a little bit today about leveraging the cloud to become data-driven. Because as we all know, data is the new gold? It's the new oil. No, because these analogies, they break down. And we actually have to stop using these analogies because data has intrinsic value. It is valuable. Data is the enabler for us to get faster time to value and higher ROI on projects that save lives, save money, save time, uncover new opportunities. That's what data is. So let's stop using those analogies and let's talk about what data actually does for us. But it only works if we have a data platform or data estate that enables our insights and automates our actions. Without that, the data just sits there. We don't actually get a faster time to value. We don't actually get a higher ROI. So, yeah, we need a data estate. We need a data platform to take that data, to give us the information we need to inform through enabling insights, to perform by automating actions. This is a 5-year-old quote. It still stands. If we don't leverage the data, we will get left behind. In fact, with the way things are going for a lot of us, if we don't leverage our data, we will die. We're not going to be able to survive the way things are going right now. We're seeing another turnaround from what we saw 5 years ago. We're seeing it happen again. No idea how long it'll last, but leveraging the data, generating efficiencies, uncovering new opportunities is critical for us. All right, great. Let's go build a data estate. Let's go build a data foundation. But to build it, it has to actually enable a lot of scenarios. In the current world, we have to enable automating fleet and field. We have to be able to enable observing our operations. We have to enable data science, experimentation, triggering events, event-driven architecture. These are only some of the scenarios we're going to face. And that's a lot of scenarios, which means that's a lot of capabilities that our data estate has to be able to handle. How many of us have been through the 3-2-1 of a data warehouse? $3 million, 2 years, one moderately successful, sometimes one use case, sometimes one big failure, 3-2-1. Or how many of us have been through the $10 million ERP that turned into $20 million, that turned into $50 million, and still disparate processes and people in the middle of those systems? Big bang is really, really difficult. And the reason why big bang approach is really, really difficult is we have to handle all 4 of these challenges at the same time. We have to get awareness and acceptance from our stakeholders. We have to manage budget. We got to be timely, or else we're not going to get. We got to be timely because we missed the boat on the problem, or because we're not going to get adoption without that. And if we're not careful, we end up with a whole bunch of disconnected solutions that are unsustainable as a batch, as a set. So if we try and tackle the awareness and the acceptance components, and we go in and we say, all right, we're going to build you something, it'll solve your problem, but we're only going to look at it from the solution, from the problem you have. We'll manage the budget, we'll try and be timely, but the solution is broken. Yeah, the solution is independent. It's not a platform approach. Okay, we'll deal with the solutions by building out a giant behemoth project, but we just blew the rest of the 3. Cloud changes the way we're able to attack any problem we have. It's not about attacking all 4 independently. It's about attacking all 4 at the same time. And the only way to do that is by being iterative and use case driven. And the way the cloud allows us to do that is we can take any 1, any 2, any 3, any 5, out of the platforms that are now available to us in the cloud from a data perspective, stitch them together to focus on the use case that matters to the party that we're trying to help. Build out a proof of value. But while we build out that proof of value in a timely fashion, we also build towards a reference architecture. We don't build the whole reference architecture. We identify the capabilities. We know we're going to have to be able to handle a lot of different scenarios. But we build towards it one slice at a time. We prove the value one slice at a time. We consume a small portion of that budget one slice at a time. And the more we start to drive towards awareness and acceptance, the more we get our stakeholders, our partners, our organizations accepting, realizing, recognizing that the data is valuable, we are able to get faster time to value, higher ROI, we start to open up the wallets. In the entrepreneurial world, you'll hear a fair amount about hearts, then minds, then wallets. We got to capture what's dear to the stakeholder who we're trying to convince, and that is the value that they're trying to see. We got to convince them that it was successful. Show it to them, and then chase the money after that. And the more we drive an iterative solution to solve a problem, and that iterative solution starts to build out our platform, the more we save on the budget, because we reuse the components that we built. Why? Because we're driving towards that reference architecture. We're driving towards the capabilities that we needed. And we're able to build on top of that. The important thing here is we have to be use case driven. We have to start with the business problem. We begin with the business problem. We prove the value. We go iterative. We've talked about that. We go cloud first. Why cloud first, though? Why cloud first? Well, because, number one, we can deploy within days. Once we understand, in the Azure stack, there are about 24 platform components that we can stitch together that we can use. The key about those 24, though, is they already have the hooks built in to attach any of those other 24. So as we think about the problem we face, we cherry pick the pieces we need to solve the problem we have, connect them the way we want against our reference architecture, and we're able to deploy that within days, build into that platform what we needed for the problem, and drive towards a scripted infrastructure for DevOps and DataOps. So when we have to manage this in the future, it's part of our forever plan. We have to change our mindset when we embark on this path, because now we're entering an iterative model in perpetuity. It's a program perspective, it's a platform perspective, it's a department perspective. We're not building this once, we're building slices, we're baking it in, and as we go along, we're going to have to incorporate continuous improvement. It has to be part of our continuous cycle of customer feedback loop, build, measure, learn, minimum viable product, continuous integration, continuous improvement, continuous delivery. That model allows us to adapt to the changes that are going to happen. Just some really easy stats. Fortune 500, 300 of the Fortune 500s are different today than they were 20 years ago. The implication of that is if you don't pivot, if you don't adapt, you will fall out, you will fall behind, you will die. That means that every one of our organizations is going to pivot along business lines. And if we're not ready from a data platform perspective to go back to the use case and pivot along the use cases and build towards that business problem and incorporate a culture shift in the way we build our data platform, we're not going to survive. there are around 24 just in the Azure realm. And there's more just on the outside of this box that we may incorporate into a data estate or a data platform. It depends on the term you want to use. But you have to take the set and bring them together and stitch them together in order to both enable the insights and automate the actions. And here I've listed some Azure Analysis Services. Gives us a technology that allows us to perform rapid aggregation calculation and enables insights. API management is an example of something that gives us a governance model around an API economy for any of the services we want to put in place, allows us to automate our actions. Azure Data Factory allows us to, it's actually a form of automation within enabling insights. It allows us to orchestrate the movement of data. Power BI, critical to actually that last mile of delivery of information and enabling insights to the individuals that are going to make decisions based on what they see, to understand what just happened, to observe operations, to observe the business. Whole bunch of different storage options. I got SQL DB, SQL MI, table storage, table storage, queue storage, and blob storage, and Azure Data Lake. Which one do I choose? Well, it depends on the problem we're trying to face. Might be a combination of them. But in the end, the data estate will consume components of it. And why that matters is we no longer have to buy the whole thing. We don't have to buy a huge Hadoop cluster infrastructure, stand that up in order to facilitate data science. We can now pay as you go, purchase a slice of that, consume it for where it's needed. Likewise for the SQL aspects, likewise for the analysis aspects, likewise for Power BI. That's why cloud, from a platform perspective, has fundamentally changed the way we're able to do data and AI, the way we're able to build our data estate. And this is relatively new to the data world. A lot of the concepts of building iteratively has been around for a fair amount of time. We've all heard the word agile, we've all implemented some form of agile, we've all observed how it's not always the same thing, depending on who you're talking to. Conceptually though, the iterative delivery of something has lived for a long time in software, but the platforms were not available for us to be able to do that in data. It is now. And so we need to incorporate all of these pieces into our culture shift, into our mental model of how we're going to be able to deliver value. One last piece of information, a lot of the components you'll see, a lot of the data estates you'll see will focus on the enabling insights component. We're really, really big advocates and fans of it being a holistic approach to both sides of that equation. An IoT problem is a prime example to describe that. When you're dealing with field management or fleet management, it's not just about enabling the insights about what's happening. It's not just about the digital twin and observing it. It's also about enabling the automation of the actions that take place to expedite, to remove error, to save lives. All problems can be broken down into a combination of these. And so when we're looking at a proof of value, the proof of value in the data estate is a combination of the insights we're enabling and the actions we're automating to expedite time to deliver. Time to value. The holy grail out of this stack is actually Synapse, because Synapse Analytics, you'll speak to probably when it's coming out. Maybe you'll speak to when it's coming out. Do we know when it's coming out?
We do.
We do know when it's coming out. Oh, that's what you meant. Maybe we'll convince you to give us a sneak preview. But Synapse is a holy grail out of this realm. It actually combines a lot of the platform components we're describing here in an integrated manner. Not everybody is going to jump straight to Synapse. Synapse is immensely powerful, immensely valuable, but with a good data partner, you'll be able to stitch together solutions to do those iterations that build you towards a platform that enables you for Synapse in a really quick one-step, two-step, three-step approach instead of, okay, we've got to break it all down and rebuild it. Also, really, really important, proof of concept versus proof of value. Proof of concept traditionally is something you build up and tear down. We're not fans of that anymore. Platform as a service, PaaS, in the cloud allows us to now build proof of value. You build that value and it stands, it stays, it continues in perpetuity. It delivers a slice. With the proof of value, iteration 1, iteration 2, iteration 3, you're starting to build out your data as state. Proof of concept is a small build and a teardown. You do not need to prove the concept of cloud anymore. That's not a proof of concept you need to prove. You may face a unique situation from a business perspective where you have to prove a concept from a business standpoint. But please, please, please don't go build proof of concepts to prove a technology. These technologies have been around long enough with enough use cases, enough examples out in the world now to stop building proof of concepts to prove the technology concept. Does that make sense? Does that resonate? The proof of concept versus the proof of value, nods, shakes, I'm okay with either. Okay, cool. Okay, with that, questions after each or switch right over to
Let's go to Tyler.
all right, over to Tyler.
Just trying to double check the dates here. Can I get a clicker too? Awesome. I like this. This is probably one of the best physical spaces I've seen. You know, you've got coffee in the back, couches if you want to sleep, video games if you get bored. I was thinking when I was sitting there, I'm like, if I get quarantined, I'm coming here to spend the 2 weeks because I think it could be entertaining. So I want to give you a little bit of insight into our perspective of analytics in the cloud, some of the trends we're seeing, some of the pitfalls we've seen, and then obviously I'll save some time to touch into Synapse. Quick just pulse here in the room. How many are on the IT side of the organization? So maybe half. Okay, good. That's good mix there. And then how many have a cloud, work for organizations that have a cloud strategy or using the cloud or have some familiarity? So maybe half. Okay, good. So we got a really good blend of folks in the room here. And first of all, just kicking off some of the trends we see, and I was planning on building this out, but you get to see it all, is initially hybrid. So what we mean by hybrid is that you will, for the foreseeable future, have infrastructure on-premise and in the cloud. And so where we see organizations fail is when they say, we're going to solve a problem with data. We're going to grab a bunch of data, we grab a data scientist, they sit down, they solve a problem, they say, this is awesome, look, I get a predictive result, amazing. Where it fails is it can't be operationalized, right? The data is locked in some on-premise system, we don't have the keys to the cloud, we don't have a model we can operationalize it, our security team doesn't know how the heck we're going to secure it. So innovation dies. We need to make sure that we have a mechanism to move from ideation and innovation into operations. And so when we talk about hybrid, one thing Microsoft has always been strong at, just because we were born out of on-premise before the cloud even existed, is how do we bring those two worlds together, and how do we make sure as you start to leverage cloud technology, we are able to tie back to investments that we already have on-prem. The other thing is storage and compute. So what you'll see is a common theme here, and especially when we start talking about Synapse, is the cloud has immense amount of processing capabilities, we can scale up, and we can process all this data, but there is obviously a cost to all that processing horsepower. So the trend that we want to go down is, as you start to collect immense amounts of data, we want to separate the data storage and collection from the actual services that are being used to process that data. We do that for a few reasons. Storage is very cheap, compute is very expensive. So what I mean between the two is, if you look at some of our services like data lake storage, which is just a glorified file storage container where we dump structured, unstructured data, it runs about 2 cents per gig. So pretty inexpensive place to just dump and store data. If you think of some of our big data clusters that actually process that data, whether it's through Databricks or HD Insights or Azure Batch, any of those services that are used to actually do processing on that data, those can get very expensive. So when we talk about cloud economics, we think, let's separate those two. Let's have a mechanism, Zico touched on it, is, we know there's value in data, so let's capture all that data, and let's capture it in a very inexpensive way, and then let's bring compute and processing to that data on a as needed or where we see value basis. The other thing around cloud, and especially cloud analytics, we get excited, and I'm guilty of this as a data practitioner. We rush, we want to push solutions out, is the security aspect of it. And the way the Microsoft Cloud approaches security is different than how we traditionally think of security. When we think of security traditionally, it's we want to protect our networks, we want to lock the front door, we want to put firewalls on our network, we want everyone to have to log in. Our approach is different. We assume that there's already a breach. We assume someone's in the building that has a laptop that's going to plug into your network. We assume that someone's already been able to penetrate your firewalls and get into your cloud platform. So what we do is we build mechanisms within our cloud to block and identify any malicious activity that's occurring. So those could be as simple as multi-factor authentication, which just means when I connect to a service, if I'm connecting from maybe outside of our corporate office, it's going to ask me to validate on my phone. So for example, when I connect to Microsoft services outside of our office, I have to re-authenticate not just with my password when I'm logging in, but it sends me a text message or it asks for a facial scan for me to log in. So we really want to design modern cloud and data architectures around this assumptive breach, and that is to say, we want to use services like Azure Active Directory, multi-factor authentication, and as we build these solutions to assume that people are going to gain access, but once they get in, there's nothing they can do. The services are locked down. Containerization. Is anyone familiar with containers or Docker or Kubernetes? Any of those buzzwords? Yeah, Zico, okay. So, not surprised. So these were really born out of application development. And what we're seeing is it's really just a way, and we call them microservices or containers. It's just a way to bundle services in small, what we call lightweight containers to run within the cloud. You'll see more and more of this. If we ask you guys in 2 years or 3 years, who's familiar or who's seen of containers, you all put your hands up. It's a new trend that we're starting to see around more on the infrastructure side, which just means that in the past we used to buy a server. We used to deploy software on that server. And then we went to virtualizing that to say, well, we'll buy a server and then we'll have a bunch of virtual machines that run on that server. Okay. And then this next wave is, well, we have a server, or we have some compute, and we're going to compartmentalize all those services, and we don't even need to bundle the operating system within it. Those are going to run independent. And so I'm not going to dig into them, but it's something to keep in mind as you look at some of the trends and what we're seeing within cloud especially, and even in analytics. And then the last one is really PaaS first. So if you're familiar with, you'll hear the words IaaS and PaaS. IaaS is just infrastructure as a service. What that means is, if you look back 5 years ago when organizations started to move to the cloud, maybe 3 years ago, it was just a data center lift and shift. So you would take all the virtual machines that you run in your data center down the hall here, and you'd move them to the cloud, and cloud was just a glorified data center. So it still had your VMs and your applications and everything running, but instead of running on servers within your organization's data center, it ran on Microsoft or AWS or Google or wherever you wanted to move that. That was a trend a few years back. What we're seeing now is not IaaS, where you're just lifting those virtual machines and moving them, but PaaS. So Zico showed you all those services. Those are PaaS service, platform as a service. There's no operating system behind any of those services that you have to manage and monitor. So what does that mean? It means I don't have to install Windows Server. I don't have to update and patch operating systems. I don't have to make sure I build in redundancies. It's all built in as part of the service. So as practitioners, what we get to do is take all these building blocks or Lego blocks, build solutions with them, and not have to worry as much about resiliency and redundancy and patching and updating. Our infrastructure teams don't have to do that. And then if you have organizations that are helping you on the managed infrastructure side, it's much more efficient for them to just be managing and monitoring services as opposed to whole operating systems and whole virtual machines. So what we've seen in the last probably year or two especially is the approach to data and analytics in the cloud is PaaS first. So we want to use services in the cloud as opposed to using virtual machines and building our own. Don't go into cloud thinking, I did it this way on-prem, I deployed a bunch of virtual machines, I put redundancy between those virtual machines, I deployed software, and I'm just going to build the same thing within the cloud. That's when you have the opportunity, modernize those, leverage those PaaS services. Huge amount of cost savings from just an overhead and a maintenance perspective, and then even if you cost out solutions. The most expensive resource in cloud platforms is virtual machines, so servers. Not only are you paying for a dedicated amount of processing and compute, but you're paying for Windows Server operating systems as well. So there's a licensing component to that. Whereas the PaaS service, there isn't. It's all just built in. So that's one thing that we really advocate and that we're seeing is now this modern PaaS first approach. Kind of tying into that, and what I was talking about before, I kind of like this because it shows what we're starting to see in the industry for organizations that are starting to modernize. Is this first trend is, well, let's just use cloud as a data center. Let's get out of our data center, but let's operate in the cloud the same way we've been operating in our on-prem environment. And then as you start to get more clever and you build up wisdom, you say, no, we're going to use native cloud services. We're not going to spin up a bunch of virtual machines and build the solutions the same way. Let's just use all those Lego building blocks that we have in the cloud. And now what we're starting to see is some organizations getting too smart for their own good in the sense that there is all these native cloud services that you can build, and they're starting to say, well, you know, if I use these open source technologies, I can run them in containers, and I can run it for much cheaper, and I can use all this new tooling, and we call this, you know, cloud agnostic middleware. The ultimate goal of organizations doing this is to say, I can deploy a solution to Azure or to AWS or to Google, the same solution. It doesn't matter. I'm not tied into any technology. That is not necessarily true, and where you fail is you don't get the value out of cloud. You get the value out of cloud by leveraging those native services, regardless of which cloud platform you're using. Leverage those cloud services. If you start to get too clever, it becomes unmanageable in a production environment. You don't have skill sets to operate that. And ultimately, it is more expensive to run. So as you go down this journey, this is kind of the pinnacle of leveraging cloud, is building solutions on top of those native cloud services. So you've probably all seen slides like this before. From an analytics perspective, you know, we've been in this descriptive world for a long time, which is all that historical reporting, building data warehouses, things like that. We've moved into more diagnostics, so looking for anomalies. Predictive is all about predicting outcomes based on that data. Prescriptive is let's give guidance around what we see, so systems that don't just give a result or a predicted result back, but that tell you actions to take, or in a lot of times automate those actions. So we may have a piece of equipment that's running to a point of failure, and how do we not just alert an alarm off of that, but how do we actually send information back to that device to slow it down or shut it off? And then in our cognitive side, that's really our AI platform. So facial recognition, speech detection, image detection. We're seeing a lot of this in the energy space, especially down in Texas, where I'll give you a few examples. Theft from remote field sites. So we're seeing organizations that have remote well sites that have a lot of theft. So what they've, I believe it was Shell or Chevron who put this in, they put cameras at the remote sites. So what was happening, people were going to remote sites, stripping copper or metals out of their facilities and leaving. And then you may have a scenario where a worker comes in, is cleaning the facility or monitoring gauges, which is behavior that's completely normal. So you can't have a control center with 5,000 monitors monitoring all these sites at any given time. So what they did is they built intelligence into determining the type of behavior that constitutes normal behavior for someone being out in that site and operating versus behavior that may indicate someone's looking to steal material from the site. And so they built models based on motion detection, and they deployed those models out to smart cameras. So we don't necessarily need connectivity back to the cloud always, but those cameras themselves are able to look for those anomalies and then on an exception basis throw an alert to say, we think there may be anomalous activity at well site A3, let's get someone to take a look at it and potentially stop any theft that's in progress. The other really neat one was Shell built a camera system at their fuel stations, and if you try to light a cigarette, because apparently this does happen, people do try to smoke while filling up their vehicles, as crazy as it sounds, a speaker will come on and will say, please don't smoke while you're filling up your vehicle. Sounds obvious, but you have to be quick. It can't be someone monitoring that. So they have, and I've always wanted to test this just with a pen or something, they don't have this in Canada, this is in Europe right now. I think they're rolling it out in the US, but they have a camera system that's using cognitive services to be able to identify when someone's potentially going to light a cigarette and then make an announcement not to. Great kind of health safety use case, and what you might think is common sense always not necessarily is. So last kind of thing on AI, why we kind of see this prevalence and kind of explosion in data and analytics and AI. And there's kind of three main reasons. Today we have powerful algorithms and tools that we didn't have before. So those could be data science algorithms and cloud technology tools. We have powerful compute, which is all that processing capability of the cloud. So instead of having to buy large servers and infrastructure to process data, on demand I can spin that up and use it in the cloud. And then access to large data sets. So I agree when Zico said, the data itself is not gold, but there is gold in doing something with that data, processing it, finding the insight that's going to lead to a result, whether that's driving revenue, decreasing costs, or mitigating risk, whatever the big driver is for that use case. So we have, and Zico went through this, I'm not going to pound through all the services, we have over 400 services in Azure. So those are 400 building blocks that you have to build solutions. Of those, there's probably around 20, 30, 40 that are analytics focused. And here is really a subset of those that are in our, what we call our big data landscape. So processing, using large data volumes to get insight out of. Again, the nice thing, what I get excited about is there's so much flexibility around building blocks and building up solutions. What ends up happening is customers say, that's great, we have 8 different options to build a solution. Tell me how to do it. What's the best practice? What are patterns? What are anti-patterns? So that's why it's great to have partners like Groundswell that can kind of lead you down that path of Microsoft saying there's 400 services. How do I stitch these together? Or how do I build solutions on that? Because there isn't always an obvious way, and there's a lot of, I would say there's more anti-patterns than patterns of what you want to avoid. So kind of more recently, and again, every month, every quarter, internally, we get this slide deck. It's 400 slides of all the new things that are in Azure. So the pace and cadence of development and innovation that we're putting into cloud is immense. We're obviously not going through 400 slides of what's new in Azure today, but some of the new things that are coming out that are worthwhile to be aware of. Azure Stream Analytics is really stream processing. So traditionally, we collect data. It's very batch-based. We pull it together. We do some processing to look for some insights. How do we do that on a more real-time basis? So how do we turn those insights from I can tell at the end of the day or at the end of the month to I'm going to be able to tell as it happens? And we built a lot of new capabilities into Stream Analytics for those that have used it in the past. That service is evolving rapidly. Azure Synapse Analytics, and believe, just looking at this, actually, this is an old deck. I had some other ones as well, but Synapse we're going to touch into. So I'm going to show you what Synapse is all about and how that fits together. Azure Data Share is really about how do I share data within different cloud tenants. So where this really comes into play is if you're familiar with, people are probably familiar with things like ServiceNow or other SaaS services, right? So a SaaS service is just a provider that provides a service. So something like Gmail, right? It's your Gmail email account. That's a SaaS service. I connect to a web address, I log in, I have access to my mail. Great. So think of that from an organization's perspective. I subscribe to a cloud platform that is going to run part of my business. How do I now tie into that to capture data off of it? And so what services like Data Share are starting to do is to say a lot of these SaaS services run in Azure. They're already running in an Azure environment. They may not run in your Azure environment, but they're running in Azure. And then you have your analytics solutions and your applications that are running in your Azure tenant. How do we enable a connection on the backbone of Azure so that really these SaaS services are just an extension of what you're doing? And so that's the value of running in Azure, where you have a lot of SaaS services that are already running there. And what Microsoft wants to do is provide a 1 + 1 = 3, where there is value in being able to connect to those as if they were just an extension of your environment today. And then Azure Data Explorer, this again is a service that you will, as you move into the cloud, you will get more familiar with. One of the challenges is, especially in oil and gas and energy, is how do we process time series data, right? So we collect all this telemetry off devices, it comes streaming in. How do we do processing off those large volumes of data? Traditionally, we try and do things like, well, maybe we'll put it into Azure Data Warehouse or a big database, and there's challenges behind that. So Azure Data Explorer is a time series database geared towards analyzing time series data. So for those that have real-time use cases or telemetry use cases, this becomes your repository to start processing and analyzing that data. So, so this is I'm just gonna, I think I may have, because I had a few things on Synapse that I wanted to pull up, so let me just double check the deck here that we have. This one won't have the updates to it. I think it's a CSV. It's the third. Oh, it actually didn't copy over. Let me, from a time check, do I have time to grab it off of, or I'll just talk through it on these actually. Apologies, I had some updated slides that looks like didn't copy over to the USB here. So traditional data warehousing, right? This is traditionally what we do. We take the data, we transform it, we load it into a data warehouse. I think Zico did a good explanation of where those projects fail. I like the 3-2-1. That's good. I'll have to steal that from you. And as organizations evolve, we're kind of aligning into these two areas where we have big data platforms. So we're excited about big data and what we can do with it, and it's really quick to pull data together and look for insights. But it's really shoestring, and it's really off the side as far as we want to be fast exploration and look for new insights. And on the other side, we have our traditional data warehousing, where we have security and the data's locked down. And so we had these two worlds, and oftentimes these were two separate groups within the organization. Sometimes there was collaboration between the two, sometimes not. And we really call this like the big data lake environment, and then the data warehousing environment. Technology was separated, groups were often separated, so it posed a bit of a challenge. So through the power of PowerPoint, we merged the two together. As easy as that. But no, I mean, that's really what Synapse is trying to do, is to try and say, let's bring these two worlds together. So there isn't is this a data warehousing problem or is this a big data problem? It really should be one environment, one development interface, one solution brought together, and you get to take advantage of both areas of that. You get the integrated security and the rigor and the governance on the data warehousing side, and you get the power, the flexibility, and the ability to move quick on the big data side. And so Azure Synapse Analytics today, as it sits today, is just Azure Data Warehouse. So if you're familiar with our database as a service platform within Azure, day one was just a rebrand. And this is the biggest confusion that we have is, we have this press release, we have Synapse Analytics, it's new, and people log in, they say, that's the same service we've always seen, there's nothing new to there. So as of today, it is a rebranded service that has already existed. So it is Azure Data Warehouse. Throw something at me if you hear me say Azure Data Warehouse again, that's rebranded, it's now Synapse Analytics. It is a single service that we are now starting to extend through what we call the Synapse Analytics portfolio. So with upcoming releases and what is in private preview now, and the dates I saw were at the end of this month, it should come out of private preview into public, which means you should have access to spin it up and use it in your own tenant. And then by the end of H2 2020, which is 6 months in, so June, July timeframe, 2020, it should go into GA. So with the new Synapse, or the upcoming release, what's different about it is it's really bringing together a number of, I just want to see, so the slide I didn't have on here is bringing together a number of our services that you typically use when you build a modern data warehouse solution. So if you think about it, I ingest data, I pull it together, I'm going to use a service called Azure Data Factory, right? That's our data ingestion, data movement service. I'm going to model it, I'm going to load it into tables, that's typically Azure Data Warehouse or SQL Server. I'm going to do some processing, big data processing of it. Oftentimes we use services like Databricks or Spark. And then I want to visualize it. So I want to use Power BI and visualize it. And so in the past, these were all separate services. That's great. You bolt them together and you glue them together, but they had different interfaces. You had to stitch them together for each solution that you're building. So what Synapse does, it says, let's glue all these together and have it in a single interface, single login, which is Synapse. So ADW was the first service that we stitched in, so that's day one, that's today. So day one, Synapse is Azure Data Warehouse. Sorry to disappoint, that's all it is day one. The end of this month, you will now have access to Data Factory, Power BI, and Spark fully integrated. And then on our roadmap is already, in our internal preview of it, we already have a number of additional services that are starting to get baked in. I can't say which ones, but if you think about things like real-time and streaming and the IoT use cases, those are ones that are going to start to get baked in as well. So what Synapse brings, sure, we glued all this together, and that's great, but what it brings is this kind of ideal cloud-based architecture that we talked about, where we've separated the storage from the processing. So think of Synapse as it's an engine to process your data. That's it. If you think about where your data comes in, we can land it into something like a data lake. That's where we're going to grow. We build all this data. We pull it in. We need an engine to some compute to start processing on that data. But the inevitable question is, what do we use? Do we use SQL-based technology? Do we use Spark-based technology? How do we secure it? How do we manage it? How do we monitor it? So what we built in is obviously tight data integration to our storage layer. So Azure Data Lake Store. We have either SQL-based or Spark-based interfaces to that data. So where this is really cool, and in subsequent sessions I'll do a demo to show you guys, is I may know SQL really well. Let's say I'm a DBA or someone who's been working with data for a long time and I know SQL, I can run queries and I can run scripts. Perfect. let's say we have someone else who's great with Spark, Python, R, some of the new big data technologies. I can run a SQL job against data, and I can run a Spark job against data, and I can run it against the exact same data set. So as someone is updating data through a SQL interface, that data is now made available through someone who's accessing and using that data through a Spark interface. So in the past, those were separate services. If you remember those two bubbles that were separate, you have people running data warehouse workloads, and you have people doing Spark-based workloads, but the data was separate. You'd have to be shuffling the data between the two. Now it's fully integrated, so it doesn't matter which technology you want to use. The key is that you're leveraging off that same common data platform, and you're separating that storage from the compute. Data warehouse is what part of the three in the 321 was the 3 the million?
Yeah.
Or years?
No, 3 million.
Yeah. So the 3 is the million, and what happens is, and why data warehousing projects failed in the past, and even now with organizations trying to invest in big data, is that the technology can be expensive, can be very expensive. So if I try to sell to a business that, okay, we want to pull all your data together, we're going to load in data warehouse, it's going to take 2 years, $3 million, we don't know what the output or what the value is right now. The advantage with something like this is to say we have the data, it's there, there's not a big burn rate on that data sitting there. Let me show you what I can do on top of this data on an ad hoc, almost a pay-as-you-go basis. So both Spark and SQL will have what we call provisioned and on-demand. Provisioned just means I provisioned a bunch of compute, or I provisioned a database ahead of time to be able to process that data, and I know how much it's going to cost every month. Or on-demand just says, charge me every time I run a query. So what that means is I can load a massive amount of data, start doing on-demand queries against it to look for value with very little burn, very little cost associated with it. The on-demand model is based off of the amount of data that you're traversing. So if you're doing queries on small data sets, it's obviously a lot less expensive, but it encourages innovation. So it pushes innovation that way. And then languages, we have SQL, Python, .NET, Java, Scala, like all the common languages. Bring your language, determine the compute you want, and sit on top of a common data platform. So that's really where Synapse is going. I think we're running a bit on the time side, but it is going to be our integrated big data warehousing platform. That is where Microsoft's direction is going. It's fully integrated. The last thing I'll show you guys is kind of a preview of that studio. So the studio it's a web interface. I log in, I have access to my data, whether that's in a database or whether that's in a data lake. So to us, it's the same, access it through that interface. I can develop pipelines, I can develop scripts. Those scripts can be SQL-based, they can be notebook-based. I can build any kind of orchestration to automate and to schedule, and then I can monitor and manage. So Synapse is becoming the interface. So yes, we have 20, 40 building blocks in the analytics space that you can glue together. Where we're starting to go is this accelerated approach of saying, let's just give you one interface to start building solutions on top of. So that's it. Part of the deck, I think we're going to share the deck. I'll share the updated deck that I have for you guys. You can sign up for preview. We had, I think it was 5,000 organizations the first week sign up for the preview, and we only accepted 25. So that's why not a lot of people have had access to preview. But with it going public preview, hopefully the end of this month, you guys should have access for some hands-on. And what we thought is to tee up more of a hands-on workshop once we get access to make it real for you guys.